This is another milestone in our long-standing collaboration, and we hope there will be many more. Ladies and gentlemen, it's my pleasure to introduce you Ivan Petrovic, Senior Machine Learning Technology Lead at HTech. Ivan has navigated the complexities of AI across diverse projects involving from computer vision to machine learning and large language models. With expertise stemming from numerous cross-industry projects, Ivan is dedicated to constructing systems that harness cutting-edge technologies, empowering individuals through AI. Today, Ivan will provide invaluable insight into architecting, designing, and developing solutions based on generative AI. The title of Ivan's talk is Approach to Architecting Generative AI Solutions. Please join me in welcoming Ivan Petrovic.
Good morning, everyone. Thank you for being here so early. So the talk today is going to be about the approach to architecting generative AI solutions, and these are the three topics that I want to cover with you. The first one is going to be the introduction to non-AI folks that I hope there is someone amongst you who doesn't know what Gen AI is now. Then we will provide you with the insights on how we at HTech approach these issues and how we approach solving these issues with the framework that we have. And last but not least, the cherry on the top is the deep dive in one of the examples of the architecture that I want to present to you on how we build those dynamic systems and what is the topic of this presentation today. So as I mentioned, I hope that there is someone in the audience who doesn't know what Gen AI is, and I will try to provide you insight into what these systems are and how we can use them in our work. So the question is, what are LLMs? LLM stands for large language models, and they are basically in machine learning, you have input, you have model, you have output. The idea is to transform the data into some numerical form to be processed by these models, which are basically, in a sense, mathematical operations. And then the numerical result is then transformed again into textual representation. We are focusing only, and most of the talk today is going to be focused on the natural language processing and the text as the input, but I will cover some other things that you need to be aware of. So when we talk about how we can host these systems, we can have them in cloud or on premise, depending on the solution we are solving. We can have a third-party solution like OpenAI or Azure OpenAI services that we can utilize, or we can have a hybrid mode like combining several different approaches depending on the task at hand. And yesterday, actually on Wednesday, we heard Microsoft talking about putting these LLMs on the edge on our laptops so that we can use them in that manner. I mentioned text is the type of data that we are going to focus today, but there are also different types of data that these systems can do, and this is what we call multimodal models. In an example, you can have a text as an input, you can have image, you can have audio file, you can have signals from different kinds of sensors, and you can also have depth information. And one example of multimodal model is now GPT-4V, which can process in the same model images and textual informations. The most common use cases that we can have with building these NLP-based solutions and textual-based solutions with generative AI are these listed here. So most of these things you already know, so I won't go into details, but the idea is to be aware what you can do with the systems right now. And when we talk about how we approach these solutions, so initially when the whole hype started internally, we had to adapt to some way. So we needed to provide to our colleagues who are engineers who are not in AI space a framework or a way of thinking on how they should approach when solutioning this type of tasks. And do not go into details on what is written here because there is a lot of information here, and I want just to point out that you already know this flow. from different kinds of frameworks. So you have a problem, you have a way how to develop the solution, and then you can scale. But we created our framework called StepFrame, which is a fork. You can see it in that sense of that framework by adding this central part that is focused now on the approaches emerging in the generative AI field. And we can have like something we call cognitive design. This is a step in which we are trying to find a way how to mimic humans' behavior or humans' actions and to embed them, engineer them into this system that we are building. Also, now the security is the most pressing thing that we need to address too, because we don't want to, because these systems that we are building right now with the help of generative AI or based on generative AI can have some level of autonomy. For example, they can access our databases, they can access data, they can search the internet on some facts or some queries that we provide them with. And the idea with this security is to think upfront for providing safeguards and grounding the system in a sense to prevent those malicious behaviors to emerge. For example, if you want to build a system that's gonna access SQL database and read some data, you need to prevent it for generating query that can delete that table or that database at all. So these kinds of things you need to understand and to think about when you're designing these systems right now. And last but not least, you have these standard machine learning, AI pipelines, software engineering pipelines, because most of our colleagues working on the solutions that I'm gonna present to you later are backend engineers in .NET that scaled their knowledge with the help of AI engineers in the company and us as technology leaders to be able to build these kinds of solutions. So you are aware that there are something called prompts and prompt engineering right now, and I want just to show you that the prompts are nothing else than natural language instructions that you provide as input text to these LLMs. And the engineering part is the context that you put inside this prompt. And you can see here that one prompt can contain several key components, I would say key components, but they can be omitted or not depending on the use case. And instruction is something that for example, if you're building it can be a simple chatbot, you can provide it with the information that this is a simple chatbot that needs to answer to a user's queries. That can be an instruction. Then context, other words can be a memory. So if you're building a chatbot, this can be a previous conversation that you need to put inside so that the system knows what you talked about. The output indicator, this is something if you're trying to elicit certain behavior of these LLMs. For example, if you want to output of the system to be in a certain format, this is the piece of text that you need to input there, or piece of instructions that you need to provide, like JSON format and the structure of the JSON format that you want. And also the input data, this is what the user is going to provide to the system. For example, what is the capital of France? So the interesting point and what is the difference between the ways how we can fine-tune or how we can learn provide additional context to these systems are the ways of learning in LLM. So we have zero shot. This is same as it in classical machine learning. You don't provide any additional information to the system and you hope that the behavior will be as you want. Next one, we have one shot and few shot learning. Color coding is the same as in the previous image of the prompts, and this means that inside the context you will provide those additional examples that you want. For one shot learning you will provide one example, for few shot you will provide few shots or few examples. And then we now in the recent years, who is in the AI field, in the NLP domain itself, we are doing a lot with semantic search, semantic databases, semantic relationships between the data itself, and this is much more viable with something called vector databases, which are a new type of database that stores the information about the content in a numerical form. So it transforms the input information into some numerical representation that enables the system to search for that data semantically. For example, SQL databases or other databases, they are only gonna return exact matches depending on the query that you are providing it with. And in the vector databases, you can create a query or create a numerical representation of a query that's gonna return a similar but not the exact results of the search you are having. And this can help you, for example, if you're searching for one term and you have all the synonyms of that term in that database, to return those synonyms as a result. That's the most simple example. When you're building and when you're thinking about building these solutions, what you need to be considerate of is the first and the most important is the ethics on the system that you're building. So you need to be aware of biases, you need to be aware of those rogue behaviors that can happen. I mean, those rogue behaviors are a thing that, for example, prompt injections, this is something that you need to be aware of and to put a safeguard on them. And also the data that you are using is something that you are always thinking of, because when you're training machine learning models, you need to download the data. That data needs to have a proper license and that we can use. And also in this case, if we are using some LLMs that are trained on data that we cannot use for example, for commercial use, we are using for only research, then we cannot put these models into production. And knowledge cutoff, there is a funny story that happened for us. So we built something called the code interpreter agent, and the idea was to have an agent to have a possibility to create Python code to execute based on some command. And one of the features and one of the commands was open a PDF file and search for some information inside it. And the issue is that we use GPT 3.5 in that project, and it created Python code that's valid. But the issue was the Python code that was valid for the data that the model was trained on in 2021. And we installed the recent packages from 2023. And what we received as errors was the deprecation error. So these are the kinds of issues that you need to be aware. So we had to install those packages available in that knowledge cutoff period to be able to use this system. And there are ways to mitigate those and to make the model use those newer packages, but they are more complicated and they are increasing the complexity of the system you're building. And then what are the tokens? So I'm saying that we are providing text as input, but that's not completely true. So tokens are the ones that go in those models and they are converted into a numerical representation. And token is nothing else than, for example, you can consider a document that has 100 words, 70%, 70 words, 100 tokens will be produced from those 70 words. That's the rule of thumb ratio on when you are thinking about how much memory I need how big context do I need for those systems to be built. And last but not least, token modalities. I mentioned that you have multimodal models, so you need to have a way for transforming those tokens of representative data type into a numerical representation. You have a way for doing that. And what you can build with these systems. So depending on the complexity, there are different examples that you can have. The most simplest one is, for example, when you don't have any context, you can only create with an instruction and the input data you can provide and tell the system, okay, create a summary of a document. So the first example, the simplest one, is the document summarization. Then we increase the complexity. Then we can build chatbots. You can chat with some data that you have summarized. So you can have a memory of the system that you have built. And then we increase it even more by building tools. So the tools allow those systems that we are building to access some functionalities that it doesn't have in its way how it's built. So for example, access to a database. So we build a tool that enables this system to access a database. We can build a system that can access web search or some other tool that we can use. And last but not least, this is current what we think that is most highest complexity level of the system you can build are multi-agent systems in which you build many of these little agents that are specialized in certain areas and then make them communicating together or having some system that is overlooking on them and then deciding on the next steps or which agents to use for certain tasks. And the examples for that is AutoGPT, Baby AGI, but these are one of the examples. So let's talk about what's the main course. So when we build systems as software engineers and machine learning engineers, we need to think about reusability. We need to think about, we are building code that we can easily reuse on some other projects. We need to think about the systems powered by generative AI same way. So what we are proposing is building, separating the domain, the expertise, and the type of the system. For example, the configuration is a part of the system responsible for choosing which LLM, which prompts to use, what is the specialization of that agent that we are building. And agent type is something that we call as a summarization agent, tool, some complex agent, and so on and so forth. And combining these two, you get an instance of the agent that is what you are using in your application when the runtime is. And this enables us to change the configuration without changing the code or the implementation of the system itself. So if you are considering this as a class, configuration can be parameters that you're going to provide to a constructor of the class, and the class itself is the type of the agent. And combining these two things, you get something that can be modular and that you can easily extend per need. And now let's go into fun stuff. So the idea here is to present you what the system we have to increase our way of prototyping and building fast POCs and R&Ds. And this is only a high-level architecture of the system. And I'm going to go into details for each of the components that you need to have when building these. Some of things can be omitted depending on the task. Some things are missing here because this is only example for a chatbot system. So we don't have access to tools, for example, but it can be added. So let's dive in. The first thing, authentication. You need to have a way for users to access this application. You need to build it to be safe. You need to provide it in some sort of way. We are using this gateway component here to be a core component for communicating between different parts of the system, but you will see that it doesn't disappear. Next, we are moving to the data upload. As I mentioned before, we need to provide a way for a user to upload a document. So we need to find a way to store those information somewhere, and we are building this storage object inside the system that the system can use. And this is also a secure way because it's uploading data with a token that is enabled through authentication and so on and so forth. For rapid prototyping, you can omit, for example, if you are short on time, you can omit this part here and only hard code it to return true so that you can develop it later on. Then when we are talking about the inference flow or how the way the system looks like or how the system is used, you can see here that there is a queue in the system, and the idea of it is to separate and to decouple these two parts. So there is a user-facing part. This is the upper part, and there is agent-facing, LM-facing, and agent-facing side. This is the bottom part. And having a system here via queue, we are separating those two components because consider that you need to do a long-running task. So if a user wants to upload a document of 50 pages and then try to summarize it, it can return a result in a few seconds. But then a user wants to upload a document with 100 or 200 pages, then timeout happens and the system breaks. What you do, you increase the timeout. Okay, but then the user uploads 500 pages, then the timeout again happens. So you need to build a safe way for the users to upload any documents of any size or any number of documents in that matter, and to enable the system to run it on its own in the background and to notify a user when the document and the processing is done. That is the purpose of the queue over here. And on the bottom part, you see this proxy load service. So the component is responsible for limiting the access to the LLMs that we are using. So LLMs have, if we are talking about the third-party providers like OpenAI, they have limitations on their side that we need to be aware of. So building this system here can enable us to, in real time, switch between different services or different models if the data and informations are requiring to do that. And also on the right side, you can see that we can enable that way to have multiple different models hosted and used interchangeably because of the hybrid way of building these kinds of systems. Then I said notifications that we need to have in a sense that we need to notify a user where the system is currently. For example, ChatGPT has this feature now that it notifies the user when it's accessing certain tools, so you know that it's okay. Now they are accessing a Bing browser, then it's summarizing, then it's doing something else. This is also something that you need to provide for the solutions you are building, and it also is something more leaned and towards the user and the user experience, so that you can easily tell a user, okay, something is doing in the background, please wait, we need time for do that. And we talked about the architecture at all and the high-level overview. Now we're going to dive into a chatbot itself. So the chatbot itself, it's that dynamic agent that's presented on the previous system. And as you can see, also a complex image, but we will ease it up by creating, for example, this is the configuration. As I mentioned, you have configuration, you have a type, and this component here is responsible only for the handling this configuration things that you need to provide to the system to be able to work. Then we have agent type specific components that you need to implement and you need to use. So memory, prompt templating, prompting techniques, LM services, these are all dependent on the type of the agent that you are building. It can be a summarization, it can be some tool, it can be something else. And last but not least, this is the flow of information that goes through that chatbot. And you can see that that system can send a notification back to the user through its notification service, but also it has this LLM service responsible for accessing the desired LLM at runtime through the configuration itself. So, not to talk about how this looks like from the view of the architecture view, this is the example that we built for one of our clients, and the idea behind this infrastructure diagram is to show you that the system is modular. For example, we can easily, in the way how we build the system and design it, we can easily remove this Azure OpenAI service and replace it with some third-party or some other large language model. But also we can remove everything that is infrastructure related and to replace it with some other platform provider. Like in this case, for this client, we build a system on Azure because that's their preferred cloud provider, but the same system can be built on AWS or some other, but you need to be considerate of which of the resources you need. Everything responsible for the system, for the code itself, for the agent, it's in these boxes that can be migrated without any change in the code itself. So that would be it. Thank you for your attention.
Thank you very much. Do you have some questions?
Fantastic presentation. Thank you. Can you go back to the last slide, please? For transformation, the data processing Spark pool, which Azure service is that?
processing. Can you?
In the transformation.
Okay. So the idea for this project was to have a way for the system to. I haven't gone into details what was the problem we were solving. So for this particular case, the idea was to ingest large number of different tables, perform some operations on them, and to transform those different data tables into one unique table that we can use for this LLM to be able to access it and to query it and to reuse it. I need to go with the guys who did infrastructure part just to pinpoint which service was it exactly.
Okay. And you know which service it is for question processing, context building, and query generation?
Well,
this
is the chatbot that we built.
Oh,
so
okay.
These are the components that these components are here: authentication, question, context building, query generation. These are the parts of the chatbot itself. These are the core parts that we built.
And on the top of the business logic, next to authentication, what's the service and what's it for?
Keycloak, this one.
No, the next one.
Oh, Kubernetes. You need to scale the system. So the way how we build the system, it's to be modular. So for example, if the load on the system, on the agent itself is huge, you can decouple. We have queues to decouple the system, and we can scale those dynamic agents per need and per load of the system at that point of time. So for example, if 1,000 users would like to access some information through the chatbot, and they are all processing large amounts of data, they need time to process that. We need to scale only those components in order for the system to work. Because the system we build is containerized in a sense to be scalable.
One more question. In the ingestion part, the ingestion pipeline, which Azure tool is it?
I think that was the. I'm not sure. I need to take a look.
Okay.
This was done like 6 months ago, so.
Okay. Thank you. That's it.
Thank you very much. We have more questions. Yes.
Thanks for presentation. Really cool overview. I saw on one of previous slides that you're using memory of chat history. Are you always going to OpenAI to get an answer, or you are storing history and sometimes going to local database and saving cost on OpenAI? And what are you using? Is it relational database or what?
Thank you for the question. The OpenAI recently announced that they're gonna build stateful service. So we build this with stateless services. So the memory and everything related to data is stored on the system itself that we have built. So we are handling the memory. Actually, the memory is stored in just one.
Yeah, this was the
it's
main
stored
object
in
storage,
this.
right?
Yeah. So reading, writing, history in this main object storage.
Yeah, my question was whether you are going from web UI to main object storage to fetch questions, or you are always going to OpenAI. Are you using history if a question is repeated a couple of times, or you're always...
Oh, okay.
Something like caching layer.
I mean, it depends on the implementation itself. So I would say that depends on the implementation of the use case that you're building. So if you need to optimize certain parts like preventing same questions to appear over and over again, you need to build this logic into this chatbot agent. This system here is only a boilerplate system that you can implement in a way that you think that's best for your use case.
Thanks.
You're welcome.
Thank you very much. Do we have more questions? No?
Thank you, Ivan. Are there any technical concepts that are hard to grasp for the regular engineers beside the ML engineers, and what you do in order to provide all those concepts so the other engineers can bring like low complexity projects of this type?
Interesting question, thank you. So the idea behind the whole generative AI technology, that when it emerged in a way, is that how can we enable our engineers in the company to access and to build upon the knowledge they already have. So through the technology and the knowledge we have as AI and machine learning engineers, we are trying to educate those engineers in these areas, because frequently we've been asked by architects to provide them some consulting and help on how to approach building these solutions, because some of the things here are not listed, and there is a lot of resources online that you can use to educate yourself in this field. But it's also nice to have a person who is in this field more hands-on, in order for them to provide a proper, let's say, proper way of how to tackle this. I'm not sure if that answers.
Yeah, thank you. I have one thought in my mind. I know that, let's say, writing a prompt in some configuration or hardcore, however, people rarely figure out that that response can change through time, depending on the service.
Yeah, that is a good question. That is a good observation. Yeah, yeah. The thing is that the systems that we are building now are totally different than and not that deterministic in nature. And this is something that classical software engineering is not used to see. And when, for example, when our colleagues first reached to a point that they are building this code interpreter that generated errors, they were faced with awe of how it's possible that something I see the code works, but I'm not aware how it behaves. And also the ability of these systems to rewrite the code and to fix the errors they are having is something that is hard for engineers to grasp. But now with the co-pilots and the code helpers, they can easily understand, and they can catch up with the technology.
Thank you.
Thank you very much. Thank you, Ivan. This is for you.
Thank you.
Thank you.
Thank you.